determine the input for the converter, the controller requires a method for measuring the power. There are two different methods that can be implemented to determine the power: indirect and direct methods. Indirect methods use variables that we already know, such as the voltage, and then uses assumptions to calculate what the maximum power output would be and to adjust the voltage accordingly. Direct methods, on the other hand, use measurements of both the current and the voltage to measure the power directly and then perform a search to determine where the peak power occurs. We'll first look at indirect methods. For the photovoltaic cell, there's the voltage at the maximum power point. However, this maximum power point voltage requires knowledge about the power curve to be able to determine if we're at the peak of the power curve. Indirect measurements make an assumption about this maximum power point voltage. It's assumed that the open circuit voltage is related to the maximum power point voltage through some constant K. With this assumption, if we can measure the open circuit voltage, we can then determine the maximum power point voltage. There are two methods for determining the open circuit voltage. We can either add a photovoltaic cell along with our operating cells, which sits in the exact same condition. If we then measure the voltage across this cell, we can assume that it is equivalent to the open circuit voltage across all the other cells. The other method is to introduce a switch into our PV setup. We can then periodically open and close this switch and measure the voltage while the circuit's open. This voltage while the circuit is open will give us our open circuit voltage. We can then feed this into the controller and modify the input of our converter so that the voltage across the photovoltaic cell matches the voltage for the maximum peak power. To determine K, this is often done experimentally by comparing the power curve with the open voltage.